our last example of this unit is example number 5. So it's another rational inequality, but is the spiciest one yet. The first thing you need to do is make sure that everything is on one side. That is not true here. So I need to subtract 1 first, and then I want this to be a single fraction. So guess what we have to do? Yes, you are right. We need a common denominator. So I'm going to find my common denominator, which if you think about this term right here, it's really over 1. So my common denominator would be x plus 1, because you want your denominators to be matchy-matchy. You want them to be the same. So I'm going to multiply the top and the bottom by x plus 1. And then you just have to be so careful here. Whenever you have subtraction, it is dangerous. You are really subtracting, you're multiplying by a -1, really. So it's -1 times x, -1 times 1. So make sure you distribute the negative to all of the terms. If I do that, I'm going to have 2x minus 1x minus 1 all over that common denominator. And I definitely can combine some like terms, so I want to do that. And then I'll just have this cute inequality that reads x minus 1 over x plus 1 less than 0. So now it's just like a problem like we saw above. So I need to get those critical values. I need to find the vertical asymptote, those x-intercepts or zeros if you want to call them that. So my vertical asymptote I will find by setting the denominator equal to 0. Vertical asymptotes are always open circles, always, 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 always. So at -1, I'm going to have an open circle. Next, I'll find my x-intercepts or my zeros. So I'll set the numerator equal to 0 and solve for x. And so the x-intercepts or the zeros, you look at the inequality symbol and that's how you tell if it's going to be opened or closed. Because this is just less than, you'd have an open circle. But if this was less than or equal to, then this would be closed. So at 1, I'll plot that open circle, and now it's time to test. I have 3 sections to test. So I have 3 numbers that I'm going to plug in, and I want to see if I end up with a positive number or a negative number. I go left to right, so I'm going to test -2. I'm going to plug -2 in for x, and so -2 minus 1 is going to be negative. -2 plus 1 is also negative. And a negative divided by a negative is a positive. So I want to label the number line with those plus signs. Next up, I'm going to plug in 0. So 0 minus 1 is negative, 0 plus 1 is positive, and a negative divided by a positive is negative. So I can label that section. Last number is in this region. I'm going to go for 2, but you can plug in any number in that region. If I plug in 2, I have 2 minus 1, that is positive. 2 plus 1 is also positive. And a positive divided by a positive is positive. Now this question is asking, where is this inequality? Where is it less than 0? That means, where was it negative? Where on your number line did you label it with negative symbols? Take your highlighter and highlight the region right here. And when you write your answer in interval notation, you will have parenthesis, -1, comma, 1 parenthesis. But if this had been a closed circle, then you would have had a bracket, but it's not. So, remember when Arthur knocked everything off the table? Oh my gosh. All right, so next week it will close out this unit. So make sure that you are watching these screencasts. Well, I guess if you're listening to this, you are. But make sure you're doing your practice, office hours, after school. Like, make it happen. Make it happen, guys. Have a great week. Bye.